Hello everyone, welcome back. So today we are going to discuss another very important part of your higher level curriculum, that is differential equations. Basically, what is differential equation? As it sounds, it is differential, so calculus is there, and it is an equation, means we need to work and find some solution. So basically, differential equation is an equation that involves an unknown function that we need to find in order to solve the equation and its derivative of this function. So this is called a differential equation. For example, this is the function y is equal to x squared minus x plus 2. If you differentiate this function, you get 2x minus 1. What if you are only given dy by dx is equal to 2x minus 1? This function is not given. Then this is a differential equation with an unknown function, which is y is equal to x squared minus x plus 2. So when you solve this differential equation, you get back here. If you differentiate this again, the second derivative is 2. This is also a differential equation. So this is a differential equation, and when you solve this differential equation, you will be finding that value of y for which second derivative is 2, right? So if your differential equation contains only dy upon dx, we call it first order differential equation. If it contains the second derivative, it is called second order differential equation. If it contains higher derivatives, then the order of the differential equation will be decided by the highest derivative appearing in the equation. So quickly have a look at this mind map. In differential equation, broadly we have two types of differential equation. One is ordinary differential equation, and the second one is partial differential equation. In ordinary differential equation, unknown function depends only on one variable. Like out here in the previous example, you had y was dependent only upon x. Out here in partial differential equation, you can have multiple variables. Like when you write parametric equation, polar equation, so that has multiple variables like r, theta, t, u, v, etc. So that is called partial differential equation. In ordinary differential equation, you have only one dependent variable. So in ordinary differential equation, you can have first order differential equations, second order, third order. You can have any order of differential equation. But in your IB syllabus, you have only first order differential equation. So in first order differential equation, we had different types of differential equation. You have variable separable. You also have a homogeneous differential equation. You also have linear differential equation, etc. But remember, higher order differential equation and partial differential equation is not a part of your IB syllabus. So what you will do is only ordinary differential equation, that too only first order differential equation. Of course, there are different types. So we will see how do we solve a differential equation depending upon its type. Let's move on. So to start with, let's move with this example. So dy by dx plus 3y is equal to x squared minus 3x. Out here, if you see, what is the highest derivative present here? 1. So this is a first order differential equation. This is a second order differential equation. Solving these differential equations means finding the function which, when differentiated, gives the above form that we just discussed. So another example is when you have xy squared is equal to 2y cubed plus 1. You differentiate this using product rule. This is what you get. So this is also a differential equation. In a differential equation, it is not necessary that dy by dx is the subject of formula. It can be seen anywhere. So you can write dy by dx is equal to 6x squared minus y squared over 2xy, or you may just leave it like this. This is also a differential equation, right? So when dy by dx is 6x squared minus y squared over 2xy, when you solve it, this will be your answer. Now, how to reach this answer, we will discuss in a minute. So, let's start with variable separable differential equation. So, when I say variable separable, how does it sound? We should be able to separate variables, right? Yes. So, in some differential equations, you are able to separate variables, that x, usually x on one side and y on another side. So an example of this is dy over dx is equal to 6x squared y. So clearly, if you bring y onto the left hand side and dx onto the right hand side, x and y are separated. So let's move on. So step number one is separate your variables. So once you separate your variables, this is how it looks. Second is integrate directly. So for integration, you need to know all your methods of integration. So when you integrate both sides, integration of dy over y is equal to integration of 6x squared dx. Third step is perform this integration. So when you integrate dy over y, you get ln y. This gives you 6x cube over 3 plus a constant. Now this is, you can write as 6 over 3 is 2. So ln y is equal to 2x squared plus c. This is the solution of this differential equation. Now you see you have plus c here. So when you have plus c means it is representing a family of curves. For each value of c, you will have one correct answer. So we call it a general solution of this differential equation, which is variable separable. Now, your function may look different, but in variable separable, this is what you do. In all variable separable equations, what do? You separate your variables, integrate, write your answer. If you are given a specific value of x for another value of y, for a value of y, I mean, so you can find the value of c. And if you do this, you can get a particular solution. And such differential equations are called initial value problems that we will discuss soon. So this is how we solve variable separable differential equations. Have a look at another example. In this example, your dy upon dx is this much, y1 is equal to 3. So you have been given some value of y for a value of x. So this is an initial value problem and you will be able to find exact answer. So what do we do here? Again, can we separate variables? Yes, 2y minus 4 goes on to the left, dy comes here. So once variables are separated, this is how it looks. Integrating both sides. When you integrate, this is how it looks. Y squared plus 4 minus 4x and so on plus c. Now, when x is equal to 1, y is equal to 3. When they write y bracket 1 is equal to 3, means value of y is 3 when x is equal to 1. So just plug in these values in here. So this gives you 3 squared minus 4 times 1 and so on and so forth. So value of c will be 6. When c is equal to 6, you just replace this c by 6. And what do you get? You get y squared minus 4x is equal to x cubed minus 2x squared minus 4x plus 6. So this will be the answer to your differential equation. Since you got a specific function, not a family of functions, so this is called initial value problem. Thank you so much for watching this till end, and if you found this video useful, please consider subscribing it, like it, and press the bell icon so that you're the first to be notified of new videos. You can also reach me at jalajmaths and at jalajmath@gmail.com. And as always, till we meet again, take good care.